And in question 10, we've got a pair of parametric equations which are describing this curve C. And we're told that the point P lies on the curve C, and we're supposed to use parametric differentiation to show that the tangent to C at P has this equation. Okay, so we first need to differentiate both these guys with respect to T, put them together to find dy dx, and then use that to generate this straight line equation. Okay, so therefore, dx dt, differentiating with respect to t, I get 2t plus 3 raised to the power 1, and the differential of the inside will be 1. And that we've used the chain rule to produce our answer here. dy dt is negative 3t squared. So as I can say, dy dx, which is the gradient function of our curve C, is equal to dy dt multiplied by dt dx. Well, we've got dy dt, so this is equal to negative 3t squared multiplied by, well, the upside down version of this. But the point P we need is at x is equal to 4 and y is equal to 2. So I can say if x is equal to 4, so therefore 4 is equal to t plus 3 squared. So therefore, square rooting both sides, plus or minus 2 is equal to t plus 3. So I will get two solutions. T is equal to 2 take away 3, and t is equal to negative 2 take away 3. And we're told here that t cannot be less negative than negative 2. So this solution is blown out of the water. So if I substitute negative 1 now back into dy dx, negative 1 times negative 1 is 1, so this is negative 3 over 2 multiplied by positive 2. So this is equal to negative 3 over 4. And as we know a point, we can apply the gradient formula. So therefore, the line is given by y minus the y coordinate, which is 2, divided by x minus the x coordinate, which is 4, is equal to negative 3 over 4. Cross multiplying. So therefore, 4y minus 8 is equal to negative 3x positive 12. So what have they done? They've got the x's and y's on the left-hand side. So therefore, 4y is in the correct position. So this is 4y plus 3x. The 8 hops sides and becomes positive, and this is equal to 20, which is what they've got here. So that completes part A. Now curve C is used to model the profile of a slide at a water park. Okay, yeah, looks a reasonable slide. The units are in meters, y being the height of the slide above the water level. Find, according to the model, the greatest height of the slide above the water level. Well, the model does include the limitations of t, and the height is given by this parametric equation. So I've got that y is equal to 1 minus t cubed. So we need this to be maximum, so we've got to sub that t is equal to negative 2. And therefore I get that y is equal to 1 now plus 8, t minus 2 times minus 2 times minus 2, positive 8, and this is equal to 9 meters. And that will be the maximum height of the slide above the ground, given that t is restricted between minus 2 and 1. And that's the answer to part B of that question.